Welcome, everyone. We're very pleased today to have professors and students from Kyoto University in Japan here visiting Google. We're going to have Professor Katsumi Tanaka give us an overview of the Department of Social Informatics, Graduate School of Informatics research, and then we will have Professor Toru Ishida give us an overview of the research at the Laboratory for Global Information Network Department at the School of Social Informatics. Professor Tanaka.
Good afternoon. My name is Katsumi Tanaka from Kyoto University. And thank you very much. You kindly accepted our visit to Google. And today, I would like to briefly introduce the research activities in the area of web search in my lab. Okay. And first of all, this is a list of students and professors and also researchers from Japan. Okay. And I came from Japan, Kyoto University, and Professor Ishida also came from Kyoto University. And we have some researchers from Japanese Governmental Research Laboratory, NYCT. And also there are many graduate students of Kyoto University here. Okay, so I hope somebody in Google is watching me. Okay. And my topic is this, towards next generation search engine and browsers. So this is my image of next generation search engine. Okay, maybe intuitively, the next image of a web search engine should be a search beyond media types and places. Okay, you can see that this horizontal axis. This means the place of content storage, right? And the vertical axis, this axis denotes the media type of contents. Okay, so now we have a text search engine and also image search engine, the video search engine, right? And Google is already offering several types of content search engine. So you are now going up. I mean, not only text data, but also image retrieval and video retrieval, right? So this is one direction of conventional web search engine, right? And this horizontal axis, this is very interesting for me. I mean, currently web search engines covers, of course, web contents include blog and also desktop contents, right? And maybe now conventional web search engine is going from left to right slightly, because some search engine is now able to cover not only web, not only personal contents on your desktop, but also external database or encyclopedia or GIS contents, right? Now we are interested in this area. I mean, maybe recently television hard disk and DVD recorder, they can store many contents, right? So then maybe sometime we will need some search engine to search the content stored in hard disk and DVD record. And even the search engine for PDA contents or digital camera, right? So this is another axis, okay? So then in order to image the next generation web search, maybe we will need integrated search technology and media conversion. For example, for web contents into TV program contents, or from TV program contents into web-like contents, such kind of media conversion technology will be necessary. And very fortunately, web content has hyperlinks. And so Google was successful to give a very new ranking algorithm called PageRank. But unfortunately, for example, TV program contents in hard disk record, they don't have any hyperlinks, right? So then we may need some new non-link based ranking mechanism, right? Okay. Okay, so then from now, I will briefly sketch an overview of our research activities in the area of search engine, okay, or search technologies. And one direction is the integrated search. Okay? And this slide shows this is a TV program. And while watching a TV program, you can automatically obtain the related web page in real time. Okay? And I hear that in Google Research Lab, maybe some researcher is also engaged in this kind of research, right? So this is one example of integrated search. I mean, while you can watch TV program, you can automatically obtain related web page at the same time. Okay. And, this is another example of integrated search. This is a combination of GIS contents and web contents. Okay. And this system automatically detects some landmark places from web contents. That is based on data mining technology. And then landmark place is a very famous places in town or in any area. Okay. And furthermore, based on those landmark places, the system automatically retrieves web pages concerned with those landmark places. So this is another example of combination of GIS contents and web contents. Okay. The third one is example of image search. And I hope some people in Google listen to this story. Okay. This is an example of Google image search. And Google image search now, the precision ratio of image search is very good, pretty good. But the recall ratio of Google image search is not so bad, is not so good. Right? And this is one example. So you can try later, okay? By using a Google image search engine, why not input just three keywords: Mount Fuji and sunset and snow. Okay, so then the answer of Google image search is 0. I mean, the number of hits is 0. Okay. Okay, so then can you believe that there is no images concerned with Mount Fuji and sunset and snow in the World Wide Web big information space? The answer is no. There are many, many images concerned with Mount Fuji and sunset and snow. So then how do you improve the recall ratio of your image search engine? Okay, this is our basic, simple idea. Our idea is this: we will relax this query keyword. Okay, so then we will select Mount Fuji and sunset. Only these two keywords is input for Google image search, and the third keyword is input to ordinary text search. I mean, web Google search. And then take an intersection of these two results. So then you can find many relevant images concerned with the Mount Fuji and sunset and snow. Okay. So then you can discover many relevant images of this query. Right? This is our idea to improve your Google image search engine, especially to improve the recall ratio. And this is another example of integrated search. We have already developed a search engine to retrieve not only web content, but also TV program contents. Okay. And this is the one example. Now you can see the image, the video image of our search engine, which tries to retrieve not only web pages, but also TV program contents for your query. Okay. Now, very sorry, this is Japanese, but the user is now input the keyword space and space shuttle, right? So then this is the answer. And you can see this is a web page, this is a web page, but here this is a TV program content stored in your hard disk recorder. Okay, so then once you input your keyword query, you can retrieve a web page, but furthermore, you can retrieve a TV program contents, right? And also you can browse the returned answer. Now the user is now focusing of this answer. This is the TV program content, and if you zoom up, then you can see the detail of the TV program contents. Okay. And also, very recently, young people in Japan, while they're watching TV, they're also using PC and internet, and especially they are communicating by online chat system. So this is another example of integrated search, which tries to integrate not only TV program contents, but also online chat information. This is also very brief introductory video of this system. And this is the usual TV program. Okay, and maybe this is a user interface issue. If you zoom down, zoom out, then you can see not only the TV program content, but also here is the closed caption data. And furthermore, here is the online chat information concerned with this portion of video program. Okay. So this is another example of integrated search of TV program contents and online chat information. Okay. And this is also another example of integrated search. We already explored, developed some browser which can concurrently browse multiple websites in a concurrent manner. Okay? Suppose that you are reading newspapers. Okay? So then you can, in this system, you can read multiple web news sites concurrently. And if you pick up some your favorite news, then the related news article from other news site is automatically retrieved. And so this window is automatically synchronized with this window. So this is the image. I mean, you on your desktop, you can put two newspapers and then compare the related news articles. Okay, and this is a ranking algorithm issue. Okay, currently even PageRank algorithm is very new and very good algorithm to rank each web page. Right? Our idea is slightly different. Why do you rank web pages page by page? Okay. Our idea is to rank the collection of pages. I mean, we make page pairs from answer pages as units for ranking. So the units for ranking is not each single page, but pair of pages. Okay. So here's some example. Suppose that your query is UC Berkeley and Stanford, right? This means maybe you want to compare UC Berkeley and Stanford University. Okay, so just input the keyword UC Berkeley and Stanford. So then Google search engine will return these pages as a candidate of the answer, okay? And some page, there's much more description about UC Berkeley, but very few description about Stanford, maybe. And here, this page describes many description about UC Berkeley, but very few. This page describes Stanford very much and very few description about UC Berkeley. Okay, but maybe the intention of this query is the user wishes to compare UC Berkeley and Stanford, right? So then why don't you make a pair of these pages? So that is our idea, making a pair of pages by this and this, right? And this pair of page may be much more relevant to your query than each single page. That is the idea of ranking page collections, not page by page. right, so then I almost talked about a quick, this is a quick review of our research activities. And also we explored some new type of browser, especially browsing multimedia contents. Okay. And usually, every day we are now using Internet Explorer, that is a web browser, right? And also now, every day we watch TV. Okay. This is very usual. But our idea is the reverse. Okay. Why not watch TV, web? Why not browse TV? In order to do that, okay, so some kind of media conversion technology is needed. I mean, transform web page into TV program-like content, or conversely, transform TV program contents into web-like page, right? Okay, this is a very watching or listening. This is very passive manner to get information, right? And browsing is very active manner. Of course, Internet Explorer, every day, we click and we scroll up and down, and even we read the text on the web page. But sometimes, if we are tired, right? Maybe sometimes we may wish to just watch and listen to the web page. Okay. So then, a conventional Internet Explorer interface, it is a very active, interface. So sometimes we may wish to have a very passive and TV-like interface. Okay? And here's some example. Okay, this example is in no voice, so sorry, but this one is an example of transforming some news article web page into TV program-like contents. Okay? So then these funny characters speak each other. The topic is from some news article in some website, right? So then users can just watch and listen, something like a TV program. Okay? This is one example. Okay? If somebody can understand Japanese, this is a very funny dialogue. But anyway, sorry, this is in Japanese, right? And furthermore, no voice. Okay? And maybe this technology can be used for mobile phone or some PDA. Because mobile phone and PDA, of course, there's a very small screen. We do not, behave so actively. I mean, click and scroll up and down, So then maybe much more passive manner to read web page may be necessary. So then this kind of technology can be used. And this is a reverse, conversing TV program contents into web-like pages. Okay. Okay. I will show some short demo. This is a very short demo, but this program is running on my PC now. Okay? And this is very old news from TV. Okay? You know who he is. Okay? But anyway, okay, so this is a news program. Okay? But now, suppose that you are tired, you are boring to see this news. So you want to search another news stored in your hard disk recorder. But your hard disk recorder is huge. So it already record maybe 1 year, all the TV programs of not 1 year, but 1 week, right? So then I want to quickly search some TV news stored in my hard disk recorder. So then our interface is this. Our interface automatically tries to convert this TV program into web-like pages, just zooming out. If you zoom out, right, so then this TV program is, automatically transformed into something like a web page, right? And this text and this text, these texts are extracted from closed caption of TV program, right? And furthermore, automatically some hyperlinks is generated. Okay, so then you can quickly browse the whole contents of your hard disk record, and you can select your favorite news article. And then again, you can, if you zoom in, then you can watch the TV program. Okay. Okay, I don't have enough time, so. Okay, finally, we are now interested in the trust of web search. Okay, we have just started this research. The problem is, to what extent can we believe the result of web search engine, right? Even if your Google image search engine or Google search engine, the very good ranking algorithm is existing, but then, to what extent can we believe that the top one page is best or not? That is the problem of trust of web search. Okay? And in order to consider the trust of web search engine, maybe we should consider 3 items. The one is concerned with the content itself. I mean, the search page. So how does the search page offer fair information? Okay. In order to analyze this, of course, we can use several data mining technology, right? And the second axis is the social acceptance. I mean, if you have some web page as a search result, right, so then how do people evaluate the web page? And this is nothing so new. I mean, Google PageRank algorithm, this is one way to represent the degree of social acceptance of web page, right? But maybe we may be able to explore other technology in order to consider the trust of searched web page. And the third axis is also reliability. This means that if you are given some web page that is a top rank, right, for your query, but you cannot know how the author elaborates to create a web page or bookmarks, or, so then maybe some technology will be needed to guess how can we trust the authors of the web page. Okay, this is very important. Okay, so I have no time. So today I have some materials. I mean, by papers. So much more details. If you're interested in, you can refer, you can see. Okay, those documents. So anyway, okay. So this is my conclusion. In order to imagine the next generation search image, I pinned down several issues, especially towards next generation, maybe cross-media search beyond media types and places. This is very important, I think. And so then maybe the browsing style may be different, or may become much more variety. Okay? And furthermore, trust of search will be much more important. Okay. Right. So then, in order to realize this kind of image, I also pinned down some basic technologies we are now exploring. Okay, so thank you very much for coming here. Thank you very much.
I'd now like to introduce Professor Toru Ishida from the Department of Social Informatics of Kyoto University, who's going to talk to us about Language Grid, which is an infrastructure for intercultural collaboration. Professor?
Good afternoon. I'm Toru Ishida from Kyoto University, and I'd like to talk about my research plan. It's not a research result, but a plan for language grid, an infrastructure for intercultural collaboration. So let me start with my motivation. So we have done the so-called intercultural collaboration experiment from 2002. And so I want to talk about why I want to start a language grid project. And then I will talk about a language grid architecture, including language service ontology and language web services. And I want to work with various NPOs in Japan, including hospital support for foreign patients, university playgrounds, universal playgrounds for kids around the world, and multilingual radio program for disaster management. So we will work on this project with 3 NPOs. Okay, here is a motivation. The question is, do we really share information on the web? It seems to us no standard languages on the internet now. This is online language population survey in September 2004. From this survey, it seems English population is 35%, European languages population is more than 29%, and Asian languages is more than 26%. So we have to learn a lot of languages to understand web information. But it is, because it is impossible, we want to try to use machine translation. And if we use machine translation, we get such a result. If human translator translate, don't worry, it's nothing, then a machine translator may say, not killing trivial problems are good. So the question is, what happens when we use machine translation in intercultural collaboration? And we did an experiment in 2002, and are still continuing this experiment also in 2005. And so the experiment in 2002 is to develop open source software in Asian countries in our first languages. And 5 universities from Asia joined this project, including Shanghai Jiaotong University, Seoul National University, Handong University, University of Malaysia, and Kyoto Universities. And in this experiment, team members never meet in person, but complete software with multilingual communication tools, like web and BBS with machine translations. We did a fairly long experiment from April 2002 to December 2002. And language services were available, but we had a hard time to organize, to create the language services for this experiment. This is so-called translation pentagon we used in 2002. We used 5 languages, Japanese, English, Chinese, Korean, and Malay, and we need a machine translator to cover those languages. There are a lot of questions were there. How can we collect translation engines to cover 5 languages? How can we understand their contracts? The contracts differ, and sometimes it's really hard for us to understand. And how do we evaluate their services? There is no quality assurance in machine translation. How much should we pay for covering the 5 languages? It's a lot. It's usually $1 million for each language pair. And how can we customize provided services? And then we decided to start the project called Language Grid. We believe that language is still the biggest problem in intercultural collaboration. Though English becomes a world standard language, people don't use it in local activities. The language barrier is serious, especially in Asia, because we are not taught our neighboring languages. So I mean that Japanese are not taught Chinese or Koreans, And in China, so people are not taught Japanese or Korean, and so on. And language services are often not accessible and usable. Only big organizations like Google can buy services and create their own services. But if so people in NPOs or universities want to create their own language services, we have a lot of difficulties to access and use those services. And so our goal is to create a language grid as an infrastructure of the internet. And we want to improve accessibility and the usability of language services to develop our own language services. So here is a language grid architecture. We have two different goals. One is called horizontal language grid to provide standard language services worldwide, to create composite services by connecting existing language services upon user's request, and to develop service ontology to standardize their interface. And another goal is vertical language grid to create community language services to support intercultural activities. So this is a language grid architecture. So we have a horizontal language grid connecting standard language services, including WordNet. It's an English dictionary provided by Princeton University, or EDR. This is provided by NICT in Japan, or Chinese dictionary or machine translations between main languages. And also we have a vertical language grid to support community activities, it's like medical support, interpretation support in local hospitals. So we will work on the language service ontology to standardize APIs of existing language services, and I mean that language services is including language resources and also language processing functions like translation, paraphrasing, and so on. And we want to create community language services easily by using those service ontologies. And we also work on the language web services. So now, as you know, the standardization is in progress for web services and research in progress and semantic web services. Our goal is to create a human-agent collaboration to create composite language services. And we want to generate semantic wrapper for newly created language services. So here is language web service architecture, including 3 layers. The bottom layer is language service layer, including an atomic component and composite component and so on. The second layer is a scenario execution layer. So this is semantic web services using BPEL, WSDL, UDDI, and all. And top layer is called scenario collaboration layer. We will make a repository for service scenario and the semantic wrappers. And we are now implementing a language grid prototype, hopefully by the end of March this year. So let me introduce a few field studies we are planning with NPOs. So we are planning to work with NPOs, especially 3 purposes. One is hospital support for fallen patients. The second one is universal playground for kids around the world. And the third one is multilingual radio program for disaster management. So let me quickly review the 3 cases. The first one is the medical interpretation services at local hospitals. And the name of the NPO is Center for Multicultural Information and Assistance, located in Kyoto. So this NPO started medical interpretation service from September 2003 to assist foreign patients. And at this moment, Chinese and Portuguese are highly needed. And in this case, translation should be very accurate. And machine translation is not useful for this purpose because it's low quality. And so we need to use multilingual parallel texts. And they want to develop their own language resources, also useful for local hospitals. So this is an image how we will use language grid for this purpose. So suppose here is a multilingual parallel text for medical use. And NPO also wants to create multilingual parallel texts for some local hospital use. And if we have a similarity evaluation program for 2 sentences, we can easily create composite services by using workflow to assist interpreter volunteers. The second case is the NPO. The name of NPO is called Pangea, and they want to create a universal playground for world kids. And the NPO was launched in Tokyo by researchers from MIT Media Labs, and activities are ongoing in Tokyo and Kyoto. Overseas branches are in Korea and Kenya and Austria, and so on. And they are now collecting pictograms drawn by kids around the world. And that means they are developing their own language resources, so pictogram repositories, and grounded on the WordNet. So this is the pictogram language resources grounding on the WordNet. So they are trying to connect pictograms to the concept of in the WordNet. So this example shows how pictograms differ, different in the different countries. So, so for example, this pictogram, the meaning is morning in Japan, but it seems that this pictogram doesn't mean morning in Kenya. In Kenya, the morning should be like this. So they started to ground the meaning of a pictogram using the WordNet. So this is a new language resource created by NPO. So we have a language grid, and people can put their own language resources on the language grid. Then suppose if we have a standard language services like a Japanese Korean translation, Korean morphological analysis, and then we can easily create a workflow to create new services like this. So suppose Japanese kids input a Japanese sentence here, and then this workflow can translate it into a Japanese sentence with pictograms, and then translate it into a Korean sentence with pictograms. So the important thing is this mechanism allows NPOs to create their own language services by using their own language resources with standard language services. So third case is the name of the NPO is Kyoto Community Radio. This NPO started in March 2003, the first FM radio station by NPO in Japan. And the radio program production workshops are organized by foreign residents from May 2005 to make radio program in various languages. And especially, they want to gather and broadcast information in various languages in case of disaster, like big earthquake. So here is an example. So suppose they are different peoples from different countries using a different language to create a radio program production. So they want to need some multilingual blackboard system. And again, so they can easily create using available standard language services like a Japanese English translation and English morphological analysis, or English Hindi dictionary and so on. The point is, again, they can create their own language services for their own purposes. Okay, here is an assembly. So I introduce an architecture of language grid to increase accessibility and usability of language services. It includes two different kinds of language grids, horizontal one for connecting nations' standard languages, and vertical one for creating community language services. And we hope that an impact of the language grid is fairly big. Language services will not be created just by professionals, but by local communities. I think we want to make a positive spirals of creation, usage, and the standardization of language services. Okay, thank you very much. So here is the contributors. This is fairly multidisciplinary work. And so people are from different areas, including natural language processing, AI, agents, and sociologies, and collaborations, and so on. Okay, that's it. Thank you very much.